My dear students, today I am starting another video lecture on block diagram problem. So this is very important problem, that is, find the closed loop transfer function when input R is at station 1 and station 2. So this is the station 1 and this is the station 2. It means this is also belongs to multi input and multi output system. So to solve this problem, first we have to assume that the input R is at station 2 is equal to 0. So now let us start solving this problem. So let us assume that at station 2 R is equal to 0. Therefore, here the summing point is no more required. So now the problem is simplified to this stage. So here in place of station 1 we can put R here. So you have to find out what is C by R, or overall transfer function of the block diagram, or that is your closed loop transfer function, that is C by R. So now the problem is very simple. So if we'll shift this takeoff point to this side, then it will be very simple. If we'll shift this takeoff point to this side, the problem will be more complicated. So already I told you in my previous lecture, you should not operate the summing point and takeoff point at a time. So problem may be more and more complicated. Therefore, if you will shift this takeoff point to this side, the problem will be very much simplified. Therefore, now we will shift this takeoff point to this side. Then G3 will be, that is H3, this will be H3 by G3. So now the problem is again simplified, that is, this is a canonical form. Therefore, it is very much easy to solve this feedback path loop. So I think this will be negative. This is not positive, sorry. This will be negative. Therefore, this transfer function is equal to G3 by 1 plus G3 H2. So now we can replace this. G3 by 1 plus G3 H2. So now again we can solve this, that is, two blocks are connected in series or in cascade. Therefore, it can be combined to single block, that is G2 G3 by 1 plus G3 H2. Now again this is in canonical form. Therefore, we can now solve this feedback path loop, that is G2 G3 by 1 plus G3 H2 divided by 1 plus G2 G3 by 1 plus G3 H2 into H3 by G3. So this G3 and this G3 will be cancelled, and now we can take this LCM, that is 1 plus G3 H2. So this will be 1 plus G3 H2. So 1 plus G3 H2 will be cancelled. So now this forms like this. So this will be G2 G3 by 1 plus G3 H2 plus G2 H3 G2 H3. So now again this is connected in cascade, therefore you should remove this and this will be combined to this block. So now this is also in canonical form. So this is negative. So now we can find the transfer function of this, that is G1 G2 G3 by 1 plus G3 H2 plus G2 H3 divided by 1 plus G1 G2 G3 by 1 plus G3 H2 plus G2 H3 into H1. So now we can take LCM. This is 1 plus G3 H2 plus G2 H3. So this will be cancelled. Now the transfer function, so this is C and this is R. So this will be G1 G2 G3 divided by 1 plus G3 H2 plus G2 H3 plus G1 G2 G3 H1. So this is transfer function C by R. C by R is this much when R is at station 1. Similarly, we can find out the transfer function when R is at station 2. So to find that, let us assume that at station 1 R is equal to 0. Then similarly, by block diagram reduction technique, we can find out C by R. Thank you very much for watching this video.